Hello intellectuals, you are welcome to our today's tutorial where we'll look at the 2020 GCE Mathematics Paper 1, and this will just be a part 1. If you are new to this channel, make sure you subscribe and hit the notification bell. If you already have, thank you so much. And I just want to take this minute to appreciate everyone that has been supporting this channel and subscribing and also giving the feedback. I really appreciate you so much. Okay, so we jump into our tutorial. We'll start with question number 1, which says simplify. Okay, simplify 2a plus, in the brackets, that is b minus a, close bracket, minus 2b. When a question says simplify, if you remember in some of the previous questions, we said such questions, they are asking us to make it simple. In other words, we need to reduce some of the terms. So first of all, you check, do you have brackets? Definitely we have brackets. So we need first of all to remove brackets. Now, how are we going to remove the brackets? We are going to check on the left side of this bracket. Okay, what is next to this bracket on the left side? Correct, it is a sign, and a positive one. So we'll multiply this positive sign with all the terms that are inside the brackets. In other words, we are multiplying this sign with the signs inside the brackets. I hope we are getting it there. Okay, so now we begin. If we multiply positive times b, we'll have positive b, so it will come out like that. Then positive times negative, we'll have a negative, so it is coming out in that way. So now we have removed the brackets. Okay, what is next after the brackets? Since we are making it simple, we'll now put the like terms together. So the 2a has got its own like term, which is negative a. Remember, I'm mentioning together with the sign because I don't want to forget the sign. So as I'm arranging them, I'll make sure I carry together with the sign. So 2a, okay, 2a has got its like term, which is negative a. And as you can see, I've highlighted them with different colors. Okay, so the blue ones represent the like terms also, and then the red ones represent the like terms. So let us group them. So they will be in this way: 2a minus a. Okay, I've carried the a together with its sign, and then plus b, and then minus 2b. So now here we have like terms, we can subtract. So 2a minus a is just the same as 2 minus 1. Okay, you keep the letters, don't change their powers when you're subtracting or adding. Okay, so it's just the same as the 2 in front of this a minus the 1. I can't see any number, it means there is a 1. So 2 minus 1 is what? Good, it is just 1. So we have a, we can't write 1a. Okay, and then this side, it is just the same as 1 minus 2. So remember, again, different signs, we subtract. But first of all, we need to get the sign from the bigger number. So the b this side will have a negative. So we have a minus b as the final answer. It means we have simplified. And don't forget to write your answer on the answer space there. Okay, we proceed. The question number 2 is saying evaluate, and these are number bases. Okay, with the number bases, you check first of all what you have. So as you can see on the power there, the power is in a fraction form. Okay, the exponent or the power is in fraction form. At the same time, it has got a negative. Now with such powers with a negative, what you have to do is you deal with the base. Okay, so how are you going to remove that negative on the power? By using the base. Okay, this is what you're going to do. You need to find the reciprocal, the inverse of the base. Meaning what is down should go up, and what is up should come down. It means you have taken the inverse of that. So the 64 comes down, the 125 goes up. Then definitely the negative on the power will be removed. I hope you are following me. So we are going to have it in this way. Now that negative has been removed on the power. Then we can proceed. So we are going to introduce. Now, what it means when you have a number in the denominator, when you have a fraction, let me say so, when you have a fraction as the power, the number on the numerator represents, like this one here, the 1 represents the power, and then this represents, the 3 represents the root value. Remember that. Okay, so we are going to introduce a cube root now for this base. So cube root of 125, cube root simply means a number you are going to multiply by itself 3 times to get 125. What number is that? And the number you are going to multiply 3 times by itself to get 64. So cube root of 125 is 5, for 64 is 4. So we have our answer, and let us learn to leave our answers in mixed fraction. Don't write it as a decimal fraction, no, but as a mixed fraction. So this one can be written as 1 and then 1 over 4 as our final answer. Okay, we proceed to question number 3. Question number 3 comes from the coordinate geometry. Given that the lines 3y equals to x plus 6 and y equals to kx plus 12 are perpendicular, find the value of k. So you need to recall, when two lines are parallel to each other, we say, what do we say about their gradients? Their gradients will be the same. Perfect. But when they are perpendicular, it means they are product. When you multiply them, they give you a negative 1. Okay, so we are going to use this equation which is already known. Okay, we are going to use this to find the value for k. So let us rewrite it first, and then we need to put it in standard form. Okay, we need to have just a y this side with a coefficient of 1. So we are going to divide by a 3 on both sides. Okay, we are going to divide by a 3. Okay, so a 3 that side. If you check, I've splitted them because I want to be able to identify my gradient. Okay, that is why I've splitted these as I'm dividing. Okay, so my gradient now, I've found my gradient is a 1 over 3 as my gradient. Okay, so remember I've said when they are perpendicular, it means their gradients, when you multiply them, they give you a negative 1. That's what it means here. So gradient 1 is what we are just from finding, this number in front of x. Remember the equation for it is y equal to mx plus c. That is the reason why we need to rewrite this equation into standard form so that we are able to find the gradient, the m. So this is the m here in front of the x. Okay, that is why we are having that answer there. Okay, at the same time, we can proceed now by multiplying this, okay, with the k. So the m2 will take it as is the k. Now here we need to apply multiplicative inverse. So we are going to have the inverse of 1 over 3 is just 3 over 1, and we'll have to multiply it even on the other side, 3 over 1. So this side will give us a 1. It means k now will be equal to negative 1 times 3 will just be a negative 3. And that is the final answer for k. Don't forget, we write it on the answer space. Okay, we are done there. We proceed to question number 4. Factorize completely 6ax minus 4ay minus 3bx plus 2by. To factorize completely, remember, if we have more than 3 terms, it means we need to group. Okay, that is the factorization we are going to use. So let us group the like terms together. Now in this case, what we are going to do, we'll just group them as they are. Okay, as they are. Now remember, these are not like terms. Okay, that is why they've used the word completely. So since they are not like terms, we are going to try to find what is common between those terms that we are given. Okay, so I've paired them. Remember, here you leave your sign outside. Okay, but as you leave your sign outside here, you need to remember that this term is a negative. Even if you have taken that sign outside, remember, if it was a positive, then this term, remember, it's a positive. In this case, because there's a negative, so the 3bx, I will remember in my mind to say it has got a negative. So what is common here? Good. The 2a is common. So we take the 2a outside, we open the bracket. Now 2 dividing into 6 is giving us 3. Then a dividing into a is giving us 1. Okay, so 2 times x will just be, good, 2x. Okay, and then 2 dividing into 4 into negative 4 will just be negative 2, and then a into a 1, so negative 2 times y will just be negative 2y. So we are found there. Now remember, because we are factorizing completely, it means even this side, when we find what is common, we should find the same values inside the brackets. Okay, so here only the b is common, so I've taken the negative b. So I'm going to divide this negative with a negative for this term. Remember, we have just taken the negative outside, but it is still negative. So negative dividing into negative will give us a positive. Okay, b into b will give us 1. So negative 3 times x will give us, positive 3 multiplied by x will give us 3x. And then negative dividing into negative will give us into positive. So negative is dividing into this positive here will give us a negative. Okay, b into b will give us 1. So negative 2 times y now will have a negative 2y. So as you can see, inside the brackets now we have similar values. Okay, so we'll just cancel out 1 and write one of these inside the brackets. So let us group them like this. It means we have factorized completely. Okay, so that is the final answer there. We go to question number 5. Given that a is the point negative 2, 1 and b is the point 1, 5, find ab. These are position vectors, so they are asking us to find the magnitude of ab. These moduluses that you are seeing here, they represent magnitude, size. So what we are going to be using, there are two methods. I think the other one I'll teach you in the other question or in the other paper. For now, we are going to use the magnitude under coordinate geometry. Okay, so we are going to be using this formula here, change in x plus change in y. Okay, so looking at the two values that have been given, we can now identify, we can use these points. We can start here, x1, y2, okay, x1, y1, and then x2, y2. Okay, so once you label them, now you can begin to insert your values into this formula. Okay, so if you insert your values, you are going to have them in this way, and make sure to put brackets to separate your values nicely. Okay, so here if you multiply negative times negative, you're going to have a positive, so 1 plus 2, and then in here you're going to have 5 minus 1, so 1 plus 2 is a 3 to the power 2, and then here 5 minus 1 is a 4 to the power 2. What is 3 to the power 2 and what is 4 to the power 2? Good, so we have a 9 plus 16. 9 plus 16 is giving us 25. Now remember, in paper 1 we normally say whatever value comes from the square root, it has to come with a plus or a minus. Now here, because of these moduluses, whatever value comes from these moduluses, it comes as a positive. Okay, so we'll just write one answer from here. What is the square root of 25? A number we can use to multiply it 2 times by itself to get 25 is what? Correct, 5. So here we'll just write 5 units. That is the size. So just put the word unit. Don't put centimeters, just put the word units. Okay, so that is our answer there, 5 units. We proceed to question number 6. Use set notation to describe the shaded region in the diagram below. Now this one here, it's quite a bit tricky. Some people might get confused here, but don't get confused. You look at what is being shaded. What you can pick here is a Q intersection what? R. So that one is the first step. Okay, Q intersection what? R. That is where you're picking your values. And then what are you excluding in this case? You're going to exclude what? The P complement. Okay, so if you exclude the P, then what should come here? If you put union, you're going to include also the values in the universal set. Okay, but the universal set has not been included. It means you put the what? The intersection. So it's supposed to be a P complement intersection Q intersection R. It ends there. You get your 2 marks. We go to question number 7. Given that A is equal to 2, 3, 1, 0, matrix B is equal to negative 1, 0, x2, matrix C is equal to 7, 6, negative 1, and 0, find C transpose. To transpose a matrix simply means you are changing the rows into columns or columns into rows. So here we will need to change the rows. This is a row and this is another row. So that row, we'll need to change this first row into a column. So the 7 will be here, the 6 will be down here. It means we have changed this row into a column. And we'll change this other row into another column. Okay, like that, it means we are done. So that is the final answer there. Remember, when you see the T, simply means transpose. Make the rows into columns, the columns into rows. That's what it means. Okay, and then find the value of x for which AB is equal to C. Okay, AB is equal to C, meaning multiplying AB, the elements in A and B should be equated to C. Please don't start panicking and start multiplying everything. No, you just check where your variable is. So like in this case, my variable is just right here. So what I'm going to do, instead of panicking, I'm just going to use the first row to be multiplied to the first column, because that's where the x is. And then this first row with the first column will be equal to the first element in matrix C. That is the equation I'm going to have. So here I multiply 2 times negative 1, and then because I'm still in the same row, still same column, you put a plus. So 2 times negative 1, and then we put a plus. We are coming to 3 times x equal to what? The first element there, which is a 7. Okay, so we multiply, we have a negative 2 plus 3x equals to 7. Now here we are finding for x. So the negative 2 needs to cross the equal sign. Okay, so it has crossed, it becomes a positive, and then 7 plus 2 gives us a 9. we want to find x, so we divide by 3 on both sides, which will have us get a 3 as the value for x. So that is the final answer there. Okay, we go for question number 8. Given that the 11th term of an arithmetic progression is 43 and that of the first term is 3, find the common difference. So if you look at the information that we are given, here we've been given the nth term. So this formula here will be applied. That is why I've written down this formula for the nth term. At the same time, we need to write down the values that we have. So what do we have on the data? We have the first term, which is, if you look at the question here, we have the first term as 3. Okay, the n. Okay, the nth term, we are using the term which is given, which is 11th term. So the nth term, the n we have, which is, okay, and then we are finding the common difference. So the first term is 3, the nth term is 11, and then the common difference d is a question mark here. So let us put the values that we have. So t11th, now t11th is what? 43. So that is why here we have just substituted direct with a 43. And then the first term is a, which is 3. So put a 3 plus, and then 11 minus 1 times the common difference. And let us simplify. Okay, we have 11 minus 1, we have a 10. What is 10 times d? We are having 10d. And then here we want to remain with 10d. So the positive 3 will have to cross the equal sign. Okay, when it crosses going that other side, it becomes a negative. So 43 minus 3, the answer is what? 40. And then we divide by 10. The answer common difference is a 4. Okay, so we have our final answer there as d equals to 4. Find the fourth term. Now, since we found the common difference, it is easier to find any term now. Okay, so fourth term, we are still using the formula for the nth term, so let us write it down. So we have this formula, the t4 is equal to, the first term we are given is a 3, and then n, we are finding the fourth term, so n is 4, we are putting a 4 minus 1, the common difference, this is just what we are just from finding here, the common difference is 4, okay, so we have 4 minus 1, which is a 3, and then 3 times 4 here, we're going to have a 12, then 3 plus 12, we are having a 15, so the fourth term is a 15, and that is the final answer. So thank you very much guys for being with me up to the end of this video. If you enjoyed, please don't forget to hit the like button and share the video. Okay, so if you have not yet subscribed to our channel, make sure you subscribe for more content